Welcome back to Gabversity, my friends, where facts don't care about your feelings. It's always a pleasure to see you. So now I'm going to show you some integrals. These are mathematics integrals, James Joseph, my good friend, and they are required to complete some of the quantum mechanics physics calculations, but this is more mathematics. And what I will do is derive some of them so that you can see how deriving works, because some people here are interested in doing some derivatives. So let's begin. Number one, like your Lionscape. Ah, thank you very much. That's awesome. I'll have to do another one. All right. Integral of, and you know what? Ah, it's working again. Isn't that nice? Cos squared Ax, right? Dx. All right. I think it's time to get a magnifying glass because this phone is like an old person and needs glasses. So let's do it. Alrighty. Oh, look at that. All right. Now that, right, equals x over 2 plus sine 2ax over 4a. All right. So now let's derive it so you can see what actually happens. So we want to derive this. So the derivative with respect to x, okay, of x over 2 plus sine 2ax over 4a, okay, equals. All right, so let's derive. So x, we know that the derivative of x is 1, right? And that makes that a half. So a half plus the derivative of sine 2ax over 4a. Well, that's just a constant, so nothing happens there. The derivative of sine 2ax is 2a cos 2ax. So that's going to be 2a over 4a, which cancels out, which is half cos 2ax. Now, what is this, if anyone remembers? Right? That, if anyone remembers high school trigonometry, equals cos of ax squared, which equals cos squared ax. And there it is. So what we did was we took that, we integrated it and got that, and then we went backwards, we derived it, and we got that. So remember, the derivative of x over 2 is a half. The derivative of sine x is cos x. The derivative of sine 2ax is 2a cos 2ax. And that's just 4a. Now 2a over 4a gives a half. So there you go. Derivative of that is that, which is that, which is that, which happens to be that. There's your proof. So now you know the integral of cos squared ax dx equals x12 plus sine 2ax over 4a. Done. Now let's do the next one. Just to remind you, to give you guys a refresher, right? The dx of x squared, okay, equals 2x. d dx of x cubed equals 3x squared. Now, I don't know if you're going to see the pattern in a second, right? Of x4 equals 4x cubed. Can you see the pattern? So basically what's happening, or 2x is the same as 2x to the 1. Hey, King Whore is back. All right, so the derivative is that, okay? And the derivative of that is that. The derivative of that is that. You can see what's going on. You take that power, you put it at the front, and then you reduce that by 1. So 3 goes at the front, and then you reduce the 3 by 1, and you get 2. All right, so therefore the derivative of x, what's that going to equal? X to the 1. You put the 1 at the front times x to the 0, and x to the 0 equals 1. 1 times 1 equals 1. You see, so derivative of x is 1. There you go. right? And that's how we saw here that x is, the derivative is 1, so 1 over 2. Alrighty. Yeah. I don't know if this is really helping anyone or not. And derivatives, basically, as we said, let's say you have a graph like this one here, x squared. X squared is a graph, right? It looks like this. All right. Now the derivative is the equation of the line that touches the curve at anywhere on the curve, right? It also means if this is the distance of a particle over time, then the derivative is the speed, which I've said before, right? So this equation here, right, at this point on x equals 2x. So this equation equals 2x. Now that's the actual slope, you see? So the slope is 2x. Okay? So if right here, if x, let's just say x equals 2 here, then the slope is going to be 4, right? When x equals 9, the slope is going to be 18 in terms of the gradient, right? That's all they're saying. So they're saying that the speed is 2 times the location point, which is pretty cool. That's about it. All right, that was it. So now what I'm going to do is I'm going to do the other one for you. Okay. The next integral is this. Integral of cos squared ax dx, okay, equals, I've already done that. We just did that, which is x over 2 plus sine 2ax over 4a. Okay, we just did that. So now let's do the next one, which is the integral of sine squared ax dx, which equals, well, here's something interesting. It's x over 2 minus sine 2ax over 4a. If you notice, the integral of this is out of phase with this one by 90 degrees. So that's x on 2 plus that. That's x on 2 minus that. Right? Now, if anyone knows anything about plus c, yeah, good question, good point. Very good. Plus the constant. Well done. All right. So now what we're going to do is derive this. Now the derivative of any constant is 0. And then we're going to derive this. So therefore dx of the above. Thank you, Mr. Deltron. I appreciate it. ddx of that's a half. And then the derivative of sine is cos. So that's going to be half minus half cos 2ax. And that, if anyone remembers, equals sine of ax squared, which equals sine squared ax. Done. So we've now proved that as well. So you can see that that is that. And so we integral went up, we went around, we came back down, and there we are. Now, here's another interesting integral that we're going to need for quantum mechanics, which is the integral of sine rho x cos qx dx. I'll just call it p of x, px, sorry, equals, right, minus cos p minus q x over 2 p minus q, right, minus cos p plus q x over 2p plus q. All right, there we go. That equals that. So now, let us derive it and see what happens. Okay, so we're going to derive this. So that, right, therefore, d dx of that, the derivative of that, right, is going to equal, well, let's derive the top. If we derive the top, it's going to be p, that the derivative of minus cos x is sine. So that's going to be sine of this x, and that's going to come out the front as well, because that's the constant of derivation. So that's going to be p minus q and p minus q cancel. So we're going to get half sine p minus q x. And then here, right, we're going to get plus half sine p plus q x. Now, if anyone knows the rule, that's half sine p minus qx plus half sine p plus qx. And if anyone remembers the trigonometric function, you know the rule? If anyone remembers the rule, here is the rule. The rule is that sine of a x cos of b x equals half sine a minus b x plus half sine a plus b. Right, that's the actual rule. And if you look at that and look at that, right, that looks exactly like that. So there you go, we've proved it. So now we know the integral. Integral of sine px cos qx dx equals minus cos p minus q of x over 2 p minus q minus cos p plus x p plus q x over 2 p plus q. There you go. Not too bad, huh? Not too shabby. So I think I'll stop there because this is boring everybody. But there's a lot more integrals that we can go through later on. These are a little bit more complex, and I probably won't prove all of these. I might prove this one for you, and I'll prove this one. This one here I probably won't, because that requires an infinite sum. And I've spoken about this before. I spoke about this on the last lecture where I did the error function. That here is called the error function, but it disappears because that's a negative coefficient outside of the x up there. But it's all very exciting stuff. It's pretty cool. So these are the equations that we're going to be using in quantum mechanics. So I might do some astronomy next. Otherwise, I might just go and study on my own and then talk to you guys some other time. So welcome back to Gabversity, where facts don't care about your feelings. Cheers.